the introduction, then stability and determinacy of the beam and frame and truss. Then maybe we can only up to number 2, no? 1 and 2, because it will take some time to discuss this. So first, introduction, stability and determinacy of beam and frame and truss. So this is mentioned before, beam, frame, truss. Then analysis of statically indeterminate trusses, axial shear bending moment diagram of for frame and arches. Okay, so these are actually for beams. Then we have the same textbook, no? Actually, okay, so let us go first with the introduction. Okay. Okay. So okay, here. So a structure refers to a system of connected parts used to support load. Okay. So this is a very simple definition of a structure, no? But if you can have a longer definition than this, no? Other books, very one page, maybe one page to describe what is a structure is, but this one is only one sentence, no? A structure refers to a system of connected parts. A system of connected parts, meaning it's not only one part, okay? But just like if you have the the chair you are sitting, no? It's made up of many parts. You have the katong board nga ini mong lingkuran, napag siya mga tiil, gitawag nato og leg, chair leg, apa siya sa tiganan. Now joined together, so it's a system of connected parts, and its function is to support a load. Okay, the function of a chair is also a structure, no? Wherein the function is to support a human load, the one that sits, no? Safely, no? Safely, because if the chair will collapse and then it injured somebody, then the maker of that chair can be sued, no? For damages. Okay, why he manufactured or make some chair that is substandard, no? When the connection is not strong enough, or maybe the material is not strong enough, when if you sit it, it will just collapse, no? So it might injure somebody using it. Why? Because if you sit in a chair and then suddenly the chair collapse, it's enough to injure anybody, no? Anybody. It will injure. It's a possibility that it can injure. So the same also goes to structure. If you are making a building, no? Building is a system of connected parts, because if you see a building is made up of columns, and there are a lot of columns in a building. It's not only 1, 2, 3, 4, but maybe 100 of columns, no? And then also beams. Beams are you can identify columns on beams because most columns are vertical, no? Most columns are vertical, but not limited to vertical. A column can also be horizontal. Because the definition of a column is member subjected to compression, compressive force, no? And you will see that the vertical are subjected to compression, but not only compression, it can carry also flexure. Okay, so aside from column, there is also beam. Beam can be distinguished from column because beam are mostly horizontal member that are horizontally oriented. The orientation of its axis are horizontal. Okay, so beams, and then not only beams, there are also slabs, okay, or flooring. So flooring there are a number of floors, no? So that makes up the whole building, and then its purpose to support a load, the dead and the live load of the building. The dead load are the weight of the building itself. No? How do you determine that? Well, it's a tricky part, but computer will do that. You can also do that before we compute the weight of the building. One one column up to uh, one column after the other. No? So meaning we have to account all the column. Okay, determine the dimension of each column and multiply the volume by its density. In which if you use concrete, you use the density of concrete. You use steel, you use steel. So you have to determine the volume of the total material used in a building. That's very tedious to do. No? Imagine how many columns are there. Imagine how many beams are there. Imagine how many slabs are there. So it will take really time to do that. But you have to do that because that's where your grade are anchored. If you cannot pass, you cannot pass something like that. So and what are the live load? Well, the live loads that are not dead load. No? Live loads are not dead load. So like for example, the occupants, no? The people that uses the 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 structure, the building. So it is a dependent of the area. No, the area of the building, if the area of the building is big, meaning there is also a big area, meaning the livelihood is also big. You have also what we call the wind load. Wind load, they are livelihood because they are not they're, they are not permanent. Also earthquake. Earthquake load is not permanent. In some areas, buildings are subjected to blast, such as explosion, no? Special buildings, like if you are going to construct a bunker, so it must resist, no? It must be it must resist what they call that blast, no? Due to explosive, so like that. Or you are going to make a doomsday structure, no? So that's it. So in its simplest meaning, a structure refers to a system of connected parts used to support a load. You can actually elaborate this. No? Other books, as I have said, uh, define structure in one paragraph. Maybe some are in pages. So you have to read. No. Okay. Examples of structures. No? We have buildings, bridges, and towers. No? These are structures. As I have said, even though isa lang siya ka word, but they are system of connected parts. Like the bridges, it's a system of connected parts. You have what we call the girders, you have the abutments, you have the pier, you have the the bridge deck. So they are connected, no? And for what purpose? To support a load, to support its own weight, to support additional weight, which are the land load. Okay. So we as human, we have our own weight. So meaning we can support our own weight and we can carry also other weight, no, other than our own weight. Our structure, which is our skeleton, but we cannot see our skeleton because it's covered by our skin and our muscle. But under that, there is what they call structure, no? Structure, the bone. The bone can carry our own weight as well as other weight, no? But not too much because maybe our bone will break if we carry too much load. Unless you are really geared towards carrying weight, like you are a weightlifter. A weightlifter can carry more weight than us, than ordinary people. Okay? Why? Because they have been practicing, no? To carry weight other than their own weight. Kanang mga laborer, mga workers, tig, like for example, daghan man ta makita dinhi sa tuwa kanang isa ka truck nga bugas, mga tawo may tig kuan na tig pile na dito sa budiga, no? Taga-tagsaon na nila. Imagine isa ka truck, so ilan ang diskargatan ni butang sa budiga. To them, kung walay truck na bugas, lunli sila. Ano naman, wala man sila kwarta. They're paid per bag of rice nga ilang mabutang. No? So, the more trucks na moabot, the more happy they are because andun ilang kwarta. Okay. So, because that's their livelihood, no? To pile those bags of rice or bags of cement. Okay. So, di na sila malipay nga, mahuman na ilang trabaho nga mawala ng mga truck of rice and trucks of cement. Kaya nga naman, mawadaan na sila og trabaho. So, palampo na sila to maintain na trucks of rice and trucks of cement. Anyway, towers also, no? So, as you see, yung kayo mga towers ka, nakita na to, mga Pinto Tower. Actually, anong tower, design na siya sa mga civil engineer, no? So, siguro, once na perfect na nila ang isa ka-design, ilan na lang dahil duplicate, replicate. So, na mga tower nga halos pareha na si tower nga dili sa pareha kanan sa doon na mo mga itawag nato nga mga local consideration pausab sa design. Okay. So, but most have the same one. Now, kung maka-design na ka og isa, matrubi na gina na okay na gina siya sa tanan, so it's good one because you have only one design, you can produce 1,000 of that. Okay? 1,000 of the towers. Okay? Wala nilain. Mo na siya. Then, it will come in parts, then you can connect na lang dahil pag-abot sa field, no? Kung ilang buhaton sa field is just the foundation. The see to it that the foundation will not fail in under its own load, and even there is typhoon, the tower will be affected. So the foundation is okay. Even under earthquake is okay. So all they have to do is just to bolt them together, okay? Because it's a system of connected parts used to support the load. So those are the structure. Okay. Now, the loads on the structure, again, nanan ako ganyan, no? Dead load. Okay. Kung sama ng dead load, kanang dili na dead load yung kanang patay nga tao, dead load na sila, no? Actually, dead load yapon na sila, kaya dili na sila gamove, no? So, in the context of structure, dead loads consist of the weights of the various structural members. Okay? Mga structural members, so yapon na siya, pagbitan ka ng beam, column, slab. So, muna nga, before, I have told you nga, kung saan man ako mag-compute sa weight sa building, isa-isahon gina siya. Kung dunay 200 ka mo columns, 200 sa ka column imong computer. Kung dunay sa 300 ka beam, 300 sa ka beams sa imong computer, nga imo na din i-add up tanan. Doon na din kayo weight sa beams and columns ana niya. But take note that it's not only the beam and columns are found in a building. Doon na po na siya yung mga wall, na pa na siya yung mga canopy, na pa na siya yung atok, na pa na siya basta dagan, no? So, you are going to account all of that. Eh, ano, dili mo ma-account, dili ka ka-design sa foundation, dili mo ka-balo sa pagbabato ng building. So, that's the first thing, you know, you should know the weight of your building. In order, you can determine pila is stress sa building na i-transmit niya sa yuta. No? But that is foundation engineering. Okay, so, dead loads, no? Okay. So, very simple, the weight of the various structural members and the weight of any objects that are permanently attached to the structure. Okay? Just like, for example, na room, no? Bedroom. So, gawas nga, doon na siya dingding, doon na siya dingding o bongbong. Dingding, bongbong. Pariha ba na? Dingding o bongbong? So, pariha siguro. Huwag ang dingding, huwag Cebuano, yung bongbong bulanon. Amo ko kabalo. Bongbong, dingding. Okay. So, gawas, nga na siya bongbong o dingding, na pa na siya sa loob, na siya beam, na siya column. Tumuto siya ang mga gitawag na structural elements. No? Doon na may permanent diha. Like for example, butang ka cabinets, no? O kining mga tawag na itong mga closet. Okay. Kung permanente na ng closet niya, imo na siya consider. Cutlery. O, ito tayo mga, basta nga, anything na permanent, because ang ingon man sa dini nga, and the weights of any objects that are permanently attached to the structure. Hence, for a building, the dead loads include the weights of the column, beams, girders, boardwalk, roofing, walls, windows, plumbing, electrical fixtures, and other miscellaneous attachments. Kanang mga electrical fixtures, kanang mga suga, mga switches. Actually, gaanan na sila, pero kung matapok na sa tandagan na sila. Kanang mga plumbing, mga water closet, mga lavatory, mga tile, no? Kanang tile. Bugat na sila. So, they are also considered dead load. You have to account for all of it. Sa computer, kadit na lang kayo siya. As you model your building in a computer, yan atong itiman-andaan ang kung sa volume atong kulom yung beam. So kabalo na siya, no? Wa pa ka nagsugod siya, kabalo na lang ng computer ana. It's only a matter of accounting all of those. So, muna nga, kung magamit ka ng computer, dali agi kayo, okay? Ipadali man sa computer. Now, other drawbacks that kung grabe na kayo kakadependent sa computer, niya, panalit, like for example, ang gusto niyo mo touch button lang, niya, ang isang hindi pa touch button, papel pagyapon, o ito mga viewers. So, dili pa kayo kakakuan. So, mong, anas kayo kag computer, pero ang exam guy, dili man about computers. So, you have to learn also. That's why, dito sa theory structures, ang sa lecture, more of classical, so mga theory yun, and then sa lab, atong gamiton is kuan. Ito ng gamit ng software. Okay. So, as an example, sa beam, ini nga beam nga, mga line lang, no? Beam ni siya, doon na kay hinge, ruler on the left side, on the left support, and on the right support yung the pin or hinge. So, you can see nga, kini siya, dili kayo ni siya, kuhan, dili ni siya realistic, no? But this kind of structure appear in most structural theory, but even in statics of rigid bodies. Okay. Kung naman, wala may actual na structure nga isa dito din, no? Ay noon, na actual ani kanang beam nga gamiton sa gymnast, mo ni ani isa lang gid ka tabla ang ganyan. Ga span across the two supports, no? But in actual, mo gining actual kini kaduha mo ning actual. Doon na gid siya area, no? Even kini siya dili pa gini siya tayo kuan. Dili pa gini siya realistic. Realistic lang siya kung table siya na kanan nga table, or it could be a billiard table, or it could be a one story na shed, no? One story na shed, no? So mo ni siyang example. So ang picture lang ani is what will be the dead load if you have a line structure. This is a typical example of a line structure because it's just one line. Okay? So the load is also linear, no? Linear. The unit is kilonewton per meter. But most structure are area, no? Have the area, just like sa loob sa building. So the load is also not in kilonewton per meter, but in terms of kilopascal. Kilonewton per square meter is also a kilopascal because Newton per meter squared is a Pascal. So if you add K, so that will be kilopascal. So kilonewton per meter squared is a kilopascal unit, no? So mula ni siya ang generic niya, but the other name of this is kilopascal. Kilonewton per meter is still kilonewton per meter. But the difference between the two is this one is a linear. Why? Because it is applied to a linear structure, and this one is an area load, no? Area load or surface load. Why? Because it is applied to a surface. Meaning, if you multiply this kilonewton per meter squared into an area of the surface, you will get a concentrated load. Now we assume that concentrated load is acting at the center of gravity of the surface. So if you have a square, then it's the geometric center of the square. If it is shaped like a triangle, then the area load or the concentrated load will act at the geometric center of a triangle. So here, if you have a line load in kilonewton per meter, if you multiply that with the length, you will also get the concentrated load. And it is assumed to act at the center of the line. Okay. Line. Sa center yung sa line. So, the two figures are different. The other one is a line structure. The other one is a area structure. Surface structure. They have different types of load. One is a linear load. Another one is a surface load. Okay. So that is load and structure. Just like wind load is an area load. It comes in kilopascal or pascal. Why? Because wind will act on the surface. But you can still narrow it down into a kilonewton per meter. No? There is a technique how to convert a surface load into a linear load. Okay, so in actual, we are using materials like clay brick. So if you have 4 inches, these are the equivalent load. A 4-inch clay brick under the parenthesis is in mm. So 4 inch equivalent to 102 mm. Clay brick, it weighs 39 pounds per square foot. Okay, the PSF is pounds per square foot. Mauna siya ang unit kung gagamit ka English na unit. English. Kung sa mga yung kilonewton per meter square, dito gani in English. Well, in English gyapon siya, pero metric lang siya. Metric. So, English is what we call the first unit. Sila mag-iuna nagdala din sa mga kuan. Sila mag-iuna nag-imintuan yung mga numbers. So, dito sa na siya ilan nagsugod. Pero, speaking about units, daghan mo kayo ang units. So, naman tayo metric, naman tayo English unit. So, this is the equivalent. It is kilopascal. 1.87 kilopascal. Now, kung baga na siya, 79 na siya. No? Yeah, 3.78. Yeah. Kung mas baga pag siya kayo, imagine 12 inch. So, muna na siya. Ayan pa. So, itawag niya ni minimum design dead load. No? Na, dili, mugamit ka ni, dili gid ubos ani. So, pwede dugangan nimo. No? Now, kung doon na kayo mga frame partition and wall, kung imong wall, exterior stud wall is brick veneer, mo ni siya ang equivalent nga load, 2.3 kilopascal. Kung window, glass frame, and SAS, is 0.38. So, magdepende niya po na unsa kabaga ang glass. Wood stud, 2 by 4 inches, unplastered, na siya. No? So, mauna siya. Ang flooring, per inch niya, per mm. Mauna siya. Ang ceiling, nagyapon. No? So, these are just the minimum weight. No? Most of these load are found in the National Structural Code of the Philippines, NCP. So, makakita ka ni sa NCP. So, I will also refer you to the National Structural Code of the Philippines. And added to ang mga tables sa mga dead load. Hindi siya limited naman yung kayo. Imagine clay brick. Kung may gagamit ng clay brick sa ato kayo. Sagara, mga alublock man, no? O simento. Okay? Okay, sa floor fill, lightweight concrete plain, stone concrete, sa ceiling, acoustical fiberboard, plaster of tile or concrete. So, naan siya sa ato. Kini siya, gikan ni siya sa American Society of Civil Engineers, minimum design. Doon na tayo ato, local, aning gitawag na to, National Structural Code of the Philippines. Okay. Live loads, kung something live loads. So, kahuman na to o dead load, ini siya, dead load, magini siya, klaro kayo, dead load. Kahuman na to o dead load, ang isang klase is ang live load. Okay. Kung saan man yung live load, itong basahon. Live loads can vary both in their magnitude and location. Okay. Kung vary niya siya in their magnitude and location. Okay, building loads, the floor of buildings are assumed to be subjected to uniform live load, which depend on the purpose for which the building is designed. Magdepende din siya sa purpose for which the building is designed. Like for example, ang imong building gigamit lang siya o residensya. Residence. So, ang city, mayroon gid siya nga, okay, residensya man siya, butangan nato na siya 1.92 kilopascal. Okay. Pero kung gamiton nimo siya as office, yun siya nga, office, dagan-dagan din tao, na kay office man. So, gamit ka og 2.4 kilopascal. Daw bi kung gamiton siya nga restaurant. So, every purpose do na siya ikuan. So, nangingon ba din the floors of the buildings are assumed to be subjected to uniform live loads, which depend on the purpose for which the building is designed. Okay? Ang depende siya dahil kung sa'yo gamit sa building. Ang building wala gamit is wala pa na siya live load. Gawas kung na mga tao na puyo dito. Illegal. Highway bridge load, muna gitawag na ito ang traffic load. Diba? Kung mutabok ka sa tulay sa Marcos Bridge, puno kayo sa sakyanan, kita na ito nga magtuya-tuya ang kining tulay, no? So meaning nakabati yun siya og live load. Kung wala na siya load, tulad itong hitabo sa bago pa nagsugod ang pandemic, nangawas ang tao kay nangadlok, nakapahuway gid pagayo ang tulay. Ano man, wa man kayo moagi. Magaling moagi, duha, tulo lang ka car. Pero pag wala na nangahadlok ang tao, nagawas na, napuno sa tulay. Hindi na gali halos mulihok ang mga sakyanan sa tulay. So, nagbagot-gut ang tulay, kaya nga, bugat kayo iyang gidala. Bugat palaan ang tulay, butangan pa yung ganyan yung mga sakyanan. So, pero bridges are designed for that. Because ang structure man good, ang design niya is, ang design sa structure din define is here, refers to a system of connected parts used to support a load. So, i-design gid siya nga i-support sa load. That is our objective here in the theory of structure. We are going to design or analyze the structure subjected to different type of loadings. Okay? So that sa nekang subject which design, either steel design or concrete design, you may be able to design a structure using steel or concrete in such a way that it can support the loads. Kining mga loads, ato na ni siyang studyhan karon, no? Kung ang structure residential, so ang imong i-load sa iya, yang self-weight, yang dead load, o ang tawag na tube occupancy load. Sometimes we will apply earthquake because we do not know that during the lifetime of the structure, dunay kusog ni earthquake. Kunya, ang metabo kung wala nimo gi-include ang earthquake, nag-earthquake, so dunay additional force na nadugang sa imong structure nga wala siya na design, so ma-overstress imong structure or sometimes ma-damage siya tungod sa na-overstress siya. No? Anything that is over is not good. Like overload, overstress, anything over, no? Sa pala in over. Okay. Anything that's too much, no? Okay. Ay kanta katong sa to, too much love will kill you. Will kill you is not good. Because will kill you, man. Okay. Highway bridge load is what they call as traffic load, no? Now, may uban tulay nga dili siya subjected sa traffic. Pero agian sa tao like kanang mga footbridge, no? Uban footbridge gini agian og kanang habal-habal, no? Habal-habal kay kaagi man. Asa mo agi ang tao, makaagi mo sa ligid sa balabal. So anyway, gaanom sa nga balabal, no? And then uban bridge nga train na gid mo maagi, no? Mga yung tao na to, train, kining mga LRT o mga HRT, heavy railway track, impact loads. Kung saan man yung impact loads. Kung may impact in vehicle impact, kanang mabanggaan siya, like for example, kanang puste sa mga parking building, no? Kulba na mabanggaan sa vehicle, kusog ng dagan kay kuan mo na ilagay na yung gidako daan para pag mabanggaan siya sa mga truck, dili kay dili kay mahugno. Kung gamay lang gid siya nga puste mong gibutang, naigo lang gid sa iyang weight nga kuan. Dapat imo ginapakita pagi nga di siya mabanggaan. Kaya kung mabanggaan gid na siya, sigurado gid na siya mapilo. Kung once mapilo, apektahan na dahil na flooring so mahugno siya. Okay. So other than impact load, so nasa tayo gitawag nga wind load. So, matagas nga mga building are subjected, critical na siya sa wind load. Okay. When structures block the flow of wind, the wind's kinetic energy is converted into a potential energy of pressure, which causes a wind loading. Okay. Okay, just like if you have a building, then this wind load comes in kilopascal or surface load. If the wind load strikes into a surface area of the building, it will become a concentrated load. Okay. And which, kung yung structure is not ready for that wind load, so either matumba ni siya or mahugno. No? But if you sa theory of structures palang daan, imo nang consider ang wind load, kung earthquake load sa imong kuan, then maka-design ka o kung sa kadako ang poste, sa kadako ang beam na makaya niya ang iyang kaugalingong na naay mga tao sa sulod gawas pag yun na pag wind load. Okay. Pero ang problema kung wala nimo naakit ang wind load, that means nga ang mga poste o ang beam is para dito sa tao kung hindi siya mahugno kung iya lang kaugalingong na tao. Pero kung nagbagyo nga naay mga tao daghan, so that is additional na po niya. Na-stress sa building, pero wala man siya na-consider beforehand, so mamiligro ang building. Nga kuan. So muna dayon na kuan. Kanang imo na din siya i-retrofit. I-retrofit. Snow load. In some countries, so doon na siya snow load. No? In which wala kayo nasa ato. No? Pero if you go to countries like Japan, doon na sila snow. Even China, no? So, kinahanglan kag snow load. Ato, doon tayo gitawag og rain load. Rain load. So, ang rain man good, if our roofing, ang roofing nimo nakaslope, dili na siya magpundo. No? So, dagan dayon ang water. So, dili siya magpundo sa ato. Just like the snow. So, ang snow, imagine kung naka-snow ngayon na kabaga, bugat na kayo na. So, inala na nimo sa kaon niya, yung kalahon, i-remove. Earthquake loads. Earthquakes produce loadings on a structure through its interaction with the ground and its response characteristics. These loadings result from the structure's distortion caused by the ground motion and the lateral resistance of the structure. Okay. So, idealize structures. Actual, ano ni siya, no? Nakalga lang siya o kanang itawag nga chin block, no? Kita ni mo ni sa mga shop o kanang mga shop lagi, no? Naibugat kay nga makina, alsahon na yun. Then, usually, tuyok ni siya, pwede niya biyuhon, dalo sa line location. Okay? So, kini siya, kay fix man siya. So, mauna siya ang actual structure, sa atong idealized na structure para masolve na to, is mauna ni siya, no? Kini siya, napasabot siya, nga rigid siya sa big. So, this is what we call the rigid connection. Kaya kung pin lang ni siya, mapilo ni horizontal, mapilo na siya kung gabok ni siya kaya nga pagka-connection ni. Just like this one, this is a slab, no? A slab nga, kung kayo mga girders, so you will have, this is the plan, framing plan niya. And this equation of equilibrium is useful if your structure is itawag nato og determinate, no? Determinate. Muna siyang gamiton nimo pag-solve. Pero kung dili siya determinate, mo gamit ni gid tong mga theory of structures nga mga concept. Okay? So, here we have an example of a beam. Pero wala naman bantay time. So, tama na sa tadimi, no? Tama na sa tadimi. Okay. So, so far, kung akong i-recap, nahuman na gid ita taman abot din sa tuwan sa introduction, no? Naman na to sa introduction. So, sunod, ano na to sa beam and frame o frame structure. So, what I have what I have told you this afternoon, okay, is about the introduction, no? Okay. So, example is already about the beams, how to determine the reaction, has to do with support system. Okay. So, I will stop sharing this. Okay, and go back to you. So, Moto Class ang introduction sa theory of structures, no? So, this afternoon, akong i-explain sa inyo unsa definition sa structure in a simplest form, and unsa ang dead load o live load. Include pagkita wind load o earthquake load. Okay? Yeah. Different type of structures, no? Different type of structure. But we will still be encountering them as we go on, no? Because dili man nato ingnan nga nahuman na nato na siya, dili nato na siya ganito. In fact, if we talk about buildings, our example will be mostly buildings. Okay. Insan, nahuman na ng bridges, no? Wala pa ta kahuman, di pa ganta kabalo sa pag-analyze ang bridge ng building. So those are just introductions. So we are just dealing with the tip of the iceberg pa, no? So so that's it, no, for today, and thank you for coming. Thursday morning 9, we will have our first meeting in the laboratory. So ito lang. Okay.
Thank you, sir.
Okay, thank you for coming. So,
Thank you, sir.
i-reserve na lang na ako na question next meeting. Okay?
Okay, sir. Thank you, sir. Thank you, sir.
Bye.